so for number 1 on the exam, we want to use differentiation to find a power series representation. So our function f of x is going to be x over 3 minus x quantity squared. So we want to find a power series representation for that function. So what we need to do first is figure out what the base function we're going to be differentiating in order to get that. So this looks pretty similar to our typical 1 over 1 minus x functions. So remember a couple of different things. 1 over 1 minus x has the series representation of x to the n, where our interval is -1 to 1. So remember also that the derivative of 1 over 1 minus x is going to be 1 over 1 minus x quantity squared. So if you think about it, you have 1 minus x to the -1 power. You can bring down the -1, lower the power by 1, but you have to multiply by a negative because of chain rule, so that's why it stays positive. And this series would just be the derivative of that. So we would have n x to the n minus 1. And we would start at n equals 1. Or, sorry, no, we were going to say there. But our interval stays the same, -1 to 1. Okay. You can start at n equals 1 because the first term is 0 anyway, so that doesn't add to the series. But I don't know if your teacher is, picky about you changing the base or not. Anyway, so in this case, you can see that this looks pretty similar, except we have a 3 minus x. We're going to have to do something about that. And then we're going to multiply by x at the end. So first let's deal with our just having 1 over 3 minus x. So we need to get that into a form where it's 1 minus something. We might have a constant in front or something like that. So we need to find a way of doing that. So what you have to do is we're going to have to factor out a 3 because you need a 1 to subtract. If you factor out a 3 though, you're going to have x divided by 3 as the second term. So you can see here, these are the exact same thing. If you distribute the 3, you get this. But this is the form that we need to use that formula. And finally, what we can do is we can take the 1/3 away and say this is 1/3 times 1 over 1 minus x over 3. And now we're ready to use the power series representation. Alright, so 1/3 times 1 over 1 minus x over 3 is going to be 1/3 times the series n equals 0 to infinity. So remember that this is a constant, so we can leave that in front of the series. So 1 minus x over 3 is the same thing as this, except instead of x, we have x over 3. So instead of x to the n, we're going to have x over 3 to the n on the interval -1 to 1. So this one right here, and we could simplify that maybe a little bit, but we're going to have to take the derivative here in a second anyway. So let's make sure that the derivative doesn't do anything different in this case. If you had 1 over 3 minus x and you wanted to take the derivative of that, you would still put the -1 in front, lower the power. The chain rule here, because this changed to a 3 rather than 1, doesn't matter. The derivative of this is still -1, so we don't have to really change anything else. So then to get 1 over 3 minus x has this power series right there. So therefore 1 over 3 minus x squared must have the power series that's the derivative of that. So we still have the 1/3 constant. And if we want to take the derivative of x over 3 to the n, what we need to do then is take n, x over 3 to the n minus 1. Then we have to multiply by 1/3 due to the chain rule, because our interior derivative here is 1/3. So the last thing we need to do then to make it look like our function is we have to multiply it through by x. But there's a couple other things we could do to make this a little bit simpler. which we'll get to in a second, because if this was a multiple choice, the answers that you might see, there's a lot of answers that you could write that are equivalent, so you need to be able to switch between them. So let's see how we can write this. I could put the 1/3 out front to make it 1/9. So I have the sum from n equals 0 to infinity. I have n. So I'm multiplying this by x, so I have to split up this x into 3. So x to the n minus 1 times x over 3 to the n minus 1. Okay, so there's a couple of things that we can do here. First of all, x to the n minus 1 times x is just x to the n. And keep in mind, 9 could be rewritten as 3 squared, and I could put that inside. That would add 2 to the power of that 3. So now I want you to realize that everything that I'm writing here are all the same, depending on what you might see. So you could write this as n x to the n over 3 to the n plus 1. That's the exact same thing as what's written above it. Again, because this 9 added 2 more 3s, you could think of it, into the denominator. So its power had to be increased by 2. N minus 1 increased by 2 gives you n plus 1. Also, x to the n minus 1 times x is just x to the n. And secondly, again, like what I was talking about over here, if at n equals 0, you get a term of 0, so that doesn't add anything to the series. So this is the same as if you had just started at 1. It's the same thing. So it's possible that maybe the 1/9 is left outside, maybe not, doesn't really matter. But this right here is our power series. The last thing we need to think about, what's the interval? Well, we have a couple of different things here. First of all, in doing the derivative, we're not changing our interval. However, actually I shouldn't have written that there. Because substituting x over 3 for x, on the other hand, does change our interval. Because remember that our original function has an interval that x, or whatever is here, has to be in between -1 and 1. Well, when we started doing this part, what was the variable, or the x, in this series is not x anymore, it's x over 3. So x over 3, absolute value has to be less than 1. Meaning absolute value of x has to be less than 3, meaning x is in between -3 and 3. So doing the derivative didn't change that, but plugging in x over 3 instead of x is what changed that. Excuse me. So our power series representation is right here, nx to the n over 3 to the n plus 1, and then our interval is -3 to 3, or if it asks you for the radius, then it would